Question number 7 is exponential function. This is exponential growth. If you remember, exponential growth is something that has this term, exponential growth. It has something like p or any alphabet, p equals to p naught e to the power k t. P naught is the initial value and k is the constant of growth and t is the time taken. So this is the exponential growth model. This is what it looks like. Exponential growth can also look like some other constant a plus b e to the power kt. It can look like this as well. So when we have exponential growth, the main thing is it has to be e to the power x. This is the main idea. It has to be e to the power x. So e to the power x, they're using the letter t for growth, because time, usually for growth we use the letter t as in time. So this is an exponential growth sum. It's a very common sum in C3. So the first question, they have given a particular species of orchid is being studied. The population p at the time t years after the study started is assumed to be this expression. So given that there were 300 orchids when the study started, remember all the time they are going to give you the information when it started. So when it started or initially, it means t equal to 0. This information will always be given. So at the start, when t equal to 0, the population was 300. So population p is 300. So this information is given. Let's plug this in. So what happens? 300 equals to 2800. We don't know what a is. E to the power, if we put 0 in this, so 0.2 into 0 is going to be 0, divided by 1 plus a. Again, if t is 0, it'll e to the power 0. So this would be 300 equals to 2800 a. E to the power 0 is 1, divided by 1 plus a. E to the power 0 is 1. So if we simplify this, so multiply 300 with 1 plus a, and you have 2800 a. So if you have 300 plus 300a equals to 2800a, so therefore 300 equals to 2800 minus 300a, it's going to be 2500a. So therefore a equals to, if I send this to the other side, 300 divided by 2500, and that is going to be 300 divided by 2500, 0.12, and that's what they said. Show that a equals to 0.12. So now that we know what the value of a is, we can write this population model as 2800 into 0.12 e to the power 0.2t divided by 1 plus 0.12 e to the power 0.12 t, 0.2t. Okay. Now use the equation with a equals to 0.12 to predict the number of years before the population of orchids reaches 1850. So when p equals to 1850, we have to know what is the value of t. So let's put the value 1850 equals to, now 2800 into 0.12 is going to be 2800 into 0.12 is going to be 336. So we can write here 336 e to the power 0.2t divided by 1 plus 0.12 e to the power 0.2t. So the calculation is going to be, we cross multiply, so 1850 1 plus 0.12 e to the power 0.2t equals to 336 e to the power 0.2t. So if you multiply, it would be 1850 plus 0.12 into 1850, 0.12 into 1850. This would be 222 e to the power 0.2t equals to 336 e to the power 0.2t. So let's bring all the e to the power t on one side and then solve it. So if you write 1850 equals to 336 e to the power 0.2t minus 222 e to the power 0.2t. So then it's going to be 1850 equals to 336 minus 222. That would be 114. So 114 e to the power 0.2t. So it would be e to the power 0.2t equals to 1850 divided by 114. I'm just writing this in the reverse order because this equal to this and this equal to this is the same thing. So this would be 1850 divided by 114. It would be 16.2281. 16.2281. So 16.2281, that would be the value. So therefore, now remember, this is an exponential function sums, and we need the formula for solving e to the power x equals to a, and that would be log. So ln a. Ln means log base e. So for solving this, we need that logarithm formula. So 0.2t the power equals to ln 16.2281. Therefore t equals to ln 16.2281 divided by 0.2. So from here we can find the value of t. Therefore t equals to ln 16.2281 equals to this divided by 0.2. So that answer is 13.934. 13.934. Now, did they tell us to write the answer in a certain way? Find the number of years. So number of years, we can write it 14 years, or we can write 13.9 years. You have to give the unit, otherwise you will not get the A1 mark. The next question is actually a simple algebra sum. You have to simplify the original question into this. It's a simple algebra question rather than anything to do with growth, exponential growth. So the original question was P equals to, let me copy it from here. So P equals to 336 e to the power 0.2t. 336 e to the power 0.2t divided by 1 plus 0.2 e to the power 0.2t. So this is what happens if you put the value of a equals to 0.12 in the original expression. This is what you get. Now our job is to simplify that expression into this. We have to simplify this expression into this. So what we have to do, we have to do some simple algebra. Now first thing that we have to do is we have to get rid of this e to the power 0.2t from upstairs, from the numerator. So what we do, upstairs and downstairs, let's divide by e to the power 0.2t. So we can write P equals to, so if you divide 336 e to the power 0.2t divided by e to the power 0.2t, then you'll have 1 plus 0.2t, 0.2. Actually this is I think 0.12 because a equals to 0.12. Yes, 0.12 e to the power 0.2t divided by e to the power 0.2t. So what we get, this thing and this thing cancels off. This would be 336 and this would be 1 divided by e to the power 0.2t plus 0.12 e to the power 0.2t divided by e to the power 0.2t. So what happens, this thing and these things will cancel off, and we can write 336. If you bring this upstairs, it would be e to the power minus 0.2t and this would be only 0.12. So if we simplify this, we can write P equals to 336 divided by 0.12 plus e to the power minus 0.2 t. So this algebra is a bit cumbersome and this is only 1 mark, so I don't think in the exam you should spend too much time on sums like this, which requires you to simplify something and only 1 mark. The best thing to do is just move on to the next one, question number D. This is a very common question. They're asking us why will it be that the population cannot exceed 2800. Now you remember that e to the power x looks like this, so y equals to e to the power x looks like this. So always above the x-axis, always above the x-axis, so it cannot be equal to 0 because it is always above the x-axis. So if you write for e to the power 0.2t, this is negative, so it doesn't really matter, equals to 0. If I put 0 here, p would be equals to 336 divided by 0.12 plus 0. This whole expression would be 0 then. So 336 divided by 0.12 is 2800. Since e to the power minus 0.2 is greater than 0, it cannot be equal to 0. So the population, if this is always greater than 0, so the population will always be less than 2800, because if you are dividing 336 with more than 0.12, because this will not be 0, this will be more, so it cannot exceed. So you don't have to do the arithmetic, just say since e to the power minus 0.2t is greater than 0, the population cannot exceed 2800. So that's it.